Hello, everybody, and thank you for coming to us this afternoon. Especially thanks to all the speakers that are present today and will shed light on routes to defossilize the off-road sector. What is happening? All as eFuel Alliance, we are well represented in this sector, including the companies present today like Liebherr, Stihl, and Deutz, but also many others like Husqvarna from Sweden and Yamabiko from Japan. Why is that so? The answer lies in the specific requirements on the sector. Applications vary widely, from chainsaws, mobile cranes, excavators to snowplows. The sector is of great importance for our daily life, for example, in the construction area or landscaping. To give a few examples on requirements, big machines require a huge power output. The area of operation, for instance, for infrastructure projects in rural areas, might not have sufficient power supply for an electrical connection. Weight is a factor, for example, for chainsaws that have to be light in order to be used for working during the day. You can carry a whole battery with you. The message I want to send is the off-road sector showcases how different the way to reduce fossil fuels can be. I'm sure our panelists today will provide insights in where electrification is feasible and where other solutions like eFuels are required. Something that I consider specifically important is the study that will be presented shortly, focused on life cycle emissions. That is a way forward, because if you look at European legislation in the transport sector that determines carbon emissions, mostly we only focus on tailpipe emissions. This, in consequence, drives a shift to electrification as its only possibility to fulfill this classification. We consider this approach as misguided, as emission savings through the renewable fuels are not taken into account. We really welcome the study approach and advocate for more holistic policies. And then it is coming to technological pathways to reduce emissions. After all, we need to reduce fossil fuels and can do that best while using every technology path. This effect is risk reduction as well as fulfilling different requirements that end users pose. Technology neutrality is important to enable different routes to carbon neutrality. We are convinced that and not an or is the best approach towards our climate goals. Without further ado, I want to hand over to the study presentation of Liebherr and Frontier Economics and our moderator, Ralf Diemer. And I'm really looking forward to see the study results as well as insights from our panelists that cover manufacturers as well as fuel producers. Thank you, everyone who is with us today, and I wish you an enlightening 2 hours. And Ralf, please take over. Thanks. Thanks a lot, everybody who is making this possible.
Thank you very much, Monica, for your, as always, warm and nice welcome words. So welcome everybody else from my side. We are very happy to touch on a very different sector today. We have a lot of discussions on cars and trucks and planes and ships, mainly because they are regulated, partly heavily regulated. The off-road sector in general is not that much object of a regulation in terms of CO2. But of course, the pressure and the thinking about strategies, how to defossilize, how to get a pathway, which technologies are leading the pathway towards climate neutrality is also a very important topic in this sector. And that is why we thought it would be a good idea to present this study Monica mentioned, but also some of the players in the off-road sector, which are also members of the eFuel Alliance. And we would start with the company Liebherr. Liebherr was established in 1949. The Liebherr Group is, of course, a very well-known player in the especially construction equipment area. It's actually the biggest manufacturer in this area in the world. 50,000 people are working there in over 140 companies worldwide. And one of them is Jörg Appel. He's the head of technology coordination at Liebherr. And Liebherr also commissioned the study from Frontier Economics, and that will be the first part of our presentations and debates. So Liebherr will start giving some insights in their strategy, and also maybe also why they actually commissioned this study and what was the goal for that. And then Mrs. Theresa Steinfort from Frontier Economics will present the findings, the main findings of the studies. Just one remark again, please use the F&A section for questions. Please also commission or tell in your writing to whom you want to digest or to whom you want to ask the question. And I would like to hand that forward then right away, as we always do. We try to get all the questions you have answered. Of course, that's the most important goal also again of this event. And with that, I would hand over to Jürgen Appel to take the floor for his presentation. Jürgen, please.
Yeah, thanks, Ralf, for giving Liebherr the opportunity to present what Frontier Economics and Liebherr together have elaborated. And thanks for giving the possibility for the keynotes today. So I'm just share my screen. I'll make it like this. So you should see my screen now, hopefully. So the keynotes really.
We don't see the slides yet. Sorry, Jürgen.
No. Should be done now.
Yeah, now here we are. Working.
Okay, here we are. Oh, it's like this. Good. So really a brief description of the Liebherr group. Ralf, you mentioned already a couple of figures. You see on the left side here really a big variety of products that we are selling, which is our business. Construction equipment is of course a big business for us. By the way, we are by far not the greatest construction equipment manufacturer in the world. There are other players who has a quite also large important role. What is maybe not known, we are also producing our own components for our equipment. Here we're making own combustion engines, gearboxes, whatever it is. Great roller bearings here on the far left corner for the big wind turbines, and some other issues for railways. And I mean, we are also we're a large part for the aircraft industry as a supplier for example, landing gears or flight control systems whatsoever. So far, Ralf mentioned it, more than 50,000 people were spread over the whole globe. And why is it that important, these reducing greenhouse gas emissions for us? You see two pictures on the right side. Above, you see a big lattice boom crane. So we are part of the solution of the energy transition, which is quite good for us. You see, without these big cranes, the world would not be able to install that much renewable energy as needed for the transition. Unfortunately, on the bottom page here down below, you see a big mining truck. We are part of the problem because a lot of our equipment, or most of our equipment, is run by fossil fuel powertrains, and consumption of such a machine is, for instance, 10,000 liters of diesel per day, and you've got plenty of them in such a mine. So you see, we have a significant emission of CO2. So we need to do something. And the motto from today is all electric for off-road applications. And you see a couple of pictures from So talking about electrification, you say, okay, it could be grid-connected machines like these lattice boom crane. We're talking about battery electric machines, these small wheel loader down here, grid connection plus battery, something like this big trolley truck over here, or for instance, some kind of energy storage for construction areas. All this exists already. So you could say, is electric for off-road applications possible and thinkable? Yes, it is, and it is available already now. What do we see? Strong trends towards zero emission job sites. So tailpipe emissions should be zero. That's a clear trend. We know this from urban areas. There is not only in Europe, but of course driven from a lot of countries, not only Scandinavia, but also Dutch cities strongly recommend to not have any tailpipe emissions. And this is, of course, a big headache because this reduces the amount of possible technical solutions, quite clear. There are, of course, the next drivers is our competitions, preparing such kind of equipment. Our customers are having large programs to be or to emit less CO2 in their overall business, and it is just around all different kind of customers. You see a big port in Norway, or if we're talking about being a supplier for wind turbines, they're checking their own product carbon footprint. So this, of course, an obligation for us to do as less as possible. Others trying to be climate neutral by 2045. It's all about having at least less emissions than before. Or here's some kind of a big mining company in Australia. If it's not really zero, it's not worth doing. Yeah, I mean, this is a clear trend that customers required from us indeed zero emission tailpipe solutions, which is maybe not the answer that combustion engine guys wanted to hear, but it is one part of the story, one part of the matter that needs to be reviewed and required, of course, solutions. Nevertheless, it is what Monica mentioned, not always the best solutions of the overall lifetime of a machine. So we said, looking only at tailpipe emissions, this is not the right approach. And we said we want to have a complete approach. Of course, we want new drive systems, new drive lines, reducing less greenhouse gas emissions than what we have today. This must be one of the big requirements, of course. There is indeed another one, means technology readiness. I mean, it doesn't make any sense to have a nice solutions with reducing greenhouse gases, so we'll show you later, being not reliable in the field. Technologies, even drivetrains, are a major part of the machine, so there is the need to have these at least as reliable of what we know from today's drivelines. Infrastructure and availability of energy is really important. So far, fossil diesel is available all over the world. It will not make any sense to sell a hydrogen combustion engine somewhere to Africa or South America if green hydrogen, or if hydrogen is not available there, or even green hydrogen is not available, even in Europe, by the way. Yeah. So this needs to be one part of these four pillars. And the last one is, of course, an economic factor. There are customers, I mean, the customers do not make their business by having fun, but they want to earn money, and at least the overall technologies that we are bringing into the market must have at least the possibility for our customers to earn money with this. And if all these four factors come together, then we say that this is maybe a future drive concept. And I will go quickly through all these four pillars. Reducing greenhouse gas emissions, Theresa Steinfort will talk to you later, is one, is the first pillar, which means we have done this study to evaluate which really from a life cycle perspective, which drive lines for certain kind of equipment have at the end from cradle to grave the lowest emissions. This is done by the study. I will not explain this later because this will be done by Theresa. We're talking about technology readiness level, second pillar. There are different parts to for defossilization. You see it, of course, for all powertrains, increased efficiency. Yeah, is one big part. These local zero emission solutions will be in the market, having a larger share. We're pretty sure battery electric vehicles, fuel cell, grid connected. Then there are maybe these temporary local zero emissions where you said it will not work to have everything zero emission tailpipe. So there we're talking about hybrid systems, a combination of different kind of technologies, and we're talking about really CO2 neutral well to wheel, or maybe even later cradle to grave. Then we're talking about alternative fuels like eFuels or hydrogen or maybe ammonia, something like this. Is everything prepared to be sold to the customer to create benefit? Yeah. There is a clearly yes and no. Some technologies are already in the field. You see it. These are really pictures from machines that are existing. So this is a hybrid, a truck. This is a diesel truck with an electric driven drum here, which is some kind of hybrid. Yeah, saving 20, 25, up to 30% of diesel fuel. You see these the tunnel excavator hanging on the grid here, of course. It's zero emission. Why is this zero emission tailpipe? Clearly, why we need to have this. On the far right side is an excavator. It's a picture from the Bauma last year, which is run by an hydrogen combustion engine. This is the engine here. So the engine is, I would say, roughly within the next 2 years, maybe some kind of being prepared to be sold in the market. So this is only a demonstrator. So this is not. So the degree of readiness is far, but not that far that it can be brought to the market. There are some efficient systems, more efficiency when burning fuel, which are on the market. And here on the far right side, you see this is a fuel cell in our lab in Toulouse, in south of France, where we are trying to understand how fuel cell systems could work, not only the aerospace business, but also for our construction equipment. So this is still not to be seen in the market within the next 4, 5, 6 years, something like this. So still a time to go. Technology readiness level dependent on the technologies that we have. Infrastructure and availability of energy. When we're talking about eFuels, that would be nice to have, of course, because the technology challenge for our engineering departments is the lowest. Unfortunately, you know that better than me, or as well as me. The amount of eFuel is not available yet, and maybe will not be done, or will not be available within the next 5, 6, 7 years. How the situation is, we get the strong input from the eFuel Alliance team, so thank you for this. We see that it will come, so it is a great hope and a big hope that this will really come, because it will it is one part of the solutions that we see, as it could reduce the greenhouse gas emissions over the whole lifetime quite tremendously. A picture here from Haruoni. Hydrogen, we know green hydrogen is not available yet, but will come. That's growing slowly. Hydrogen has, for the construction equipment, of course, one big challenge. Our machinery will not come to the fueling station, but the fueling station needs to come to our machine. And how to fill up tanks in a quite fast possibility is some kind of headache, is some kind of homework that needs to be done with of course potential suppliers for us. Yeah, I mean, this is a complete solution. Doesn't make any sense to sell a machine and then having not a concept how to fill the machine later on the job site. One thing is also clear: the operation range or the reach of these machines is limited. When we're talking about excavators running or running, for example, for 1 week, 5 days without refueling with fossil diesel or with diesel now, we're talking about hydrogen, which is then maybe needs to be refilled every day. When we are lucky and having made our homework, otherwise it's maybe only 6 hours, something like this. So this needs to be investigated. Storage concepts, of course, I mean, we are only a small business, so we need to rely on what maybe trucks are doing. We see that there is so far still the trend to go towards gaseous, high pressure, 700 bar hydrogen storage. And maybe later on, we're talking about ammonia and methanol, which will be one part of the solution as a transport medium for hydrogen. And of course, we are also relying on informations coming from associations or from the eFuels Alliance. And we know we have discussed a couple of times with some shipping companies and they are talking maybe of ammonia, others of methanol. So where the road there is still not quite clear, but one of both is of course favorable for them. So we need to check for the equipment where we use huge amount of energy, like these big mining trucks, where maybe ammonia could be a suitable solution. Economic factor for future fuels. This is one slide, one copy out of a study that Lars Hummel recently sent to me. And we did different kind of studies in the aerospace industry, but nevertheless, more or less all the studies, I mean, they differ a bit, but generally we would say later on ammonia will have the lowest costs. That's what we think. Hydrogen creates additional costs, though it needs to be produced before the ammonia, but as hydrogen is difficult to store and to transport and to refuel, this will create additional cost. Unfortunately, eFuels will have at least highest costs. And of course, you all know that also it depends where the production is and how to transport all the energy to then later on to Europe or the place where it needs to be. And this needs to be reviewed or is being reviewed by Liebherr frequently to may not change this, but to understand how our customers will think and what technical solution is maybe feasible, as this is going to be the last pillar. So what are the challenges we are facing? And I mean, it's a good time for engineers, to be honest, because it's interesting issues towards this. I like this really very much because it's going deep into the heart of the machinery, drivetrains. So challenges, of course, the technology is challenging, storing these different materials, these different molecules like ammonia or hydrogen, how to store it, how to handle these equipment combustion and exhaust after treatment for these kind of materials is, of course, a big issue, a big topic. Batteries is, of course, nice. Technology is still far, but unfortunately, a lot of our equipment is driving on the road. So size and weight of batteries is a big headache, yeah, for mobile trains, for all the equipment running on streets where axle loads are limited. It's a big factor. Coming towards a complete organization, you heard that we are all over the globe, 140 companies, so service points all over all continents, and trying to train all the people for these new technologies, high voltage, when we're talking about batteries, high pressure, toxic materials. So this is a big challenge, organizational challenge for a company, because all these technologies needs to be technologies that's missing, needs to be serviced worldwide. And still, when we're talking about regulations, there is still an unclear roadmap for off-highway machinery. Yeah, US, there is maybe a new standard coming from CARB in the end 20s, so still in this decade they are discussing. Unfortunately, CARB, we have discussed with CARB, they are not friendly towards combustion technology in any kind. When we discussed, they said they see a clear trend towards complete electrification of the non-road machinery sector, which is not good for us. Nevertheless, it is as it is today. European Union, we heard that it's maybe not a new regulation will come in this decade, maybe in 10 years, something like this. Hydrogen combustion could be an option, is not regulated yet. There is no clear definition of zero and low emission vehicles. This could be sorted out and could be done. And of course, when you're looking down these portable emission measurement systems, in-service conformity for combustion engines is a clear trend, which gives us some headaches if you have only a small amount of machinery in the market. Yeah, then talking about 10 machines per year, and if you want to have then 60% of these PEMs, then it's going to be a critical situation for us. And so it creates a lot of costs. So all this is some part of the challenge. Nevertheless, we are working on, we have a widespread departments of engineering all over Europe and US. We're working on these issues, and yeah, a challenging time, but makes some fun to be part of the journey. So, well, this is the end of my keynotes. If you have any questions, feel free.
Yeah, thank you very much for this kickoff. I think very interesting insight and overview on the challenges you have actually. Of course, what you also can see here very clearly, it's a very diverse portfolio we are talking about, very different applications. And I think this is something we will see also from the presentations later on. And of course, we will have some fuel producers, which could maybe answer your question you rose, when are the fuels actually available? Let's see how this will play out later on. So I have no questions in the chat right now. My suggestion would be we are going on with the study now, because I think that is also a very interesting part to trigger more questions and to get more input on the different pathways. And we will have, and I personally for sure have also some more questions for you later on. So far, thank you very much, Jürgen, for your presentation. So I would hand over right away to Teresa Steinfotz. She's working for Frontier Economics. Of course, Frontier, not only in the circles of the eFuel Alliance, a very well-known organization, but also in the field of CO2 climate policies, very well known, working in Brussels very close also with the European Commission and with the German government, for example, as well. I remember working with Frontier already when we were in my previous job, when we were working in VDA on CO2 targets for cars, for example. Teresa is a manager for energy practice, so she's since 8 years dealing with energy policy from different perspectives. She did, or she conducted actually the study we are talking about, commissioned by Liebherr. Different pathways are based on life cycle analysis for the off-road sector. And without further ado, I would suggest, Teresa, please take the floor and give us what you found.
Thank you very much. I hope everyone can hear me, and I will also try to share my screen.
Perfect.
Do you see?
Presentation mode, and then that's it. Wonderful.
Okay. Great. So thank you very much. Ralf, you already mentioned Frontier Economics. So I keep that very short. For those of you who haven't heard of us, we are one of the largest economic consultancies in Europe with much more than 300 economists in 7 European offices. We work with a wide range of clients from the private sector, but also governments, regulators, other public authorities, and in a wide range of sectors. In Germany, we focus on the competition sector and also the energy sector and all sectors that are energy consuming, so the automotive, the transport, but also the heating or industry sectors. Now on the study, on the background and objective of the study. With the Paris Agreement and the Green Deal, the European Union and the member states have committed to limiting global warming to preferably 1.5 degrees Celsius compared to pre-industrial levels. And if we think about what that means and what we need to do that, we need to think about the nature of greenhouse gas emissions. And it is the case that wherever and whenever you emit greenhouse gas emissions worldwide, those accumulate in the atmosphere, and the more they accumulate in the atmosphere, the more global warming increases. That means in order to achieve the target, we need to reduce that greenhouse gas emission. And we need to make sure that the budget isn't overcome. On the right-hand side, we see a picture from Show Your Budgets, and the black line shows the actual emissions we have each year worldwide. And if we imagine we continue on constant level with these emissions, so we imagine a further horizontal line, then the budget of greenhouse gas emissions we are allowed to emit before we overcome the global warming targets is surpassed already at the end of this decade. So that shows that we need to act quickly. And if we imagine a different path where we immediately start to reduce emitting greenhouse gases, and if we, for example, followed this light blue path and would manage to reach a net zero economy by, say here, 2036, that would mean that with this path, we would actually be in line with the 1.5 target by at least 66% probability. So it really depends on the path and what we do and how we reach net zero for whether we can achieve the targets or not. And depending on the path, we need to be quicker or have a little bit more time to reach net zero. But in general, it is clear we don't have much time left. So that means we need to think carefully about how we use the left greenhouse gas budget we have, how we use it in order to follow an efficient path. That means that all the sectors, all technologies, governments, in coordinating with each other, they need to think about how to reduce their carbon footprint. That's a task for each player, each stakeholder, each company, and that is also what Liebherr does and has been doing. And therefore, Liebherr commissioned Frontier Economics to analyze, firstly, what is the role of construction machines on the pathway to net zero? And then secondly, what are conclusions based on life cycle analysis for the different construction machines? So starting first with the role of construction machines, it is quite evident, and Jürgen Appel already gave us some insights before with some much more impressive pictures than the ones we found here. But construction machines are indispensable for creating a defossilized economy. Some examples. On the left-hand side, we have the expansion of renewable energy plant capacity, which is needed to produce renewable energy. And if we just take the example of erecting a wind turbine, that illustrates very well that we need firstly an excavator for digging the pit, then we need a truck concrete mixer for building the concrete foundation, a wheel loader that handles the raw materials in the different gravels and cement plants. And then quite, obviously here, for erecting the tower and then also putting the wind turbine on top. The next crucial part of going towards net zero is the infrastructure. We need to expand and reconstruct that because the renewable energy we produced also needs to arrive at the end customer. And for example, we need mobile cranes to construct electricity lines, and we need excavators for digging trenches for electricity lines or gas pipelines. And then also all the way through to the end user sectors, we need to reconstruct the economy. If we take the building sector as an example, it is true that some of the heating appliances can be defossilized without construction measures. So some heating appliances that are currently run by the current electricity mix, which is still quite CO2 intensive, or run by natural gas or mineral oil or raw oil, they could be defossilized increasingly by using more and more renewable electricity, by using more and more renewable gases such as biomethane or green hydrogen, or by using increasingly eFuels. However, also a super important part of the building sector is increasing the building's efficiency. And that means a better insulation of the buildings and a construction of low energy houses. And here, wheel loaders, excavators, cranes, etc. are required. But while construction machines are quite obviously indispensable, they themselves are also emitters of greenhouse gases, and therefore they are also part of the problem and need to think about how to decrease their carbon footprint as well. In doing so, it is really important that technologies are identified and also assessed based on the emissions they emit over their whole life cycle. That means independent of whether emissions are emitted in Germany or in a different country, whether the emissions belong to that sector or a different sector, and also which year they are emitted. They all accumulate in the atmosphere. So it's important to count all of them. And the so-called lifecycle analysis does exactly that and accounts for all of these emissions, takes a comprehensive perspective, and therefore combines all of the life cycle stages. And in the mobile appliances, these are often the 5 that are illustrated here. Firstly, the construction of the machine or the vehicle itself. Then secondly, the energy sourcing, so producing the energy that is used later on, well to tank, then the infrastructure to transport the energy to wherever it's needed, and then the usage part or the tank to wheel part, and then end of life or recycling phase. And therefore the life cycle analysis offers an appropriate methodological framework for assessing technologies because it's all encompassing. And this is quite in difference to some regulations, where sometimes regulations only focus on one particular sector or one particular year or one particular country, or sometimes all combined, which is quite in contrast to the nature of greenhouse gas emissions, which are affecting the climate warming globally. But yeah, some policy instruments for mobile applications particularly focus on the tank to wheel part, or the tailpipe emissions, as Monica already mentioned. And that means that they incentivize a minimization of the greenhouse gases in that particular sector, which could mean that emissions are actually only shifted and pushed towards other sectors or other parts where the regulation doesn't focus on. And that could therefore mean that actually the contribution to the climate protection targets isn't actually that huge. The emissions are only shifted away. But life cycle analysis, they look at all of it quite comprehensively, and that is what we also did in this study. Particularly, we looked at 3 different technologies: mobile cranes, truck concrete mixers, and wheel loaders. We looked at them from cradle to grave, so looking at the 5 stages I just explained. And for each of the technologies, we looked first at the life cycle analysis of the current technological setup, which is usually a combustion engine using diesel fuel, and then also at various potential defossilization alternatives, which use a different alternative energy source and sometimes a different drivetrain as well. If we go immediately in what the life cycle analysis results show us, and we dive into the mobile crane. For time reasons, I quickly go over that page. So we have some, one more important thing is the data sources we used. So we used the lifecycle inventory database EcoInvent, which is a worldwide database for, among other, CO2 emissions. We supplemented that by scientific literature and also Liebherr data that they provided us, for example, on the consumption of the different construction machines. The mobile crane, there are some general conditions. Its life approximately lasts 25 years. And we have the annual operation data. And overall, the performance requirement of the mobile crane are quite high. So the energy it needs at a particular point in time is really high, and yeah, it's just an energy intensive high performance requirement. That's the major thing that's important here. And the technologies we looked at are, as I said, firstly the status quo technology, but also different alternatives within the combustion engine area. We looked at a mobile crane that is run by eFuels, another one that's run by HVO, and also one that is run by a hydrogen combustion engine and uses green hydrogen, and just for comparison, also the gray hydrogen. Also, we looked at a fuel cell electric mobile crane, again, run by either green hydrogen or gray hydrogen, and also purely battery electric mobile crane running on green electricity or also the current electricity mix. A note maybe on that part. In this study, we focused purely on the CO2 emissions and the life cycle analysis. We didn't assess the technical feasibility. And talking to the Liebherr staff, it sounded like really a stretch to deliver these tasks with a battery electric vehicle, just because there's so much energy required at a certain point in time, and transporting that much energy means transporting a huge battery, which is really heavy, actually too heavy to be transported on the chassis of the mobile crane. So some really technical difficulties. Nevertheless, we assessed that in this analysis, just for your information as a side mark. And this is what the results show. So on the left-hand side, you see the CO2 emissions of the current mobile crane. So it's a bit more than 1,300 tons of CO2 equivalents over a year. And then you see all the different options here. And you see that for that crane, eFuels and HVO, so the liquid alternatives, they have the greatest defossilization potential. They reduce exactly the well-to-wheel emissions, which are the largest driver of emissions in the status quo. So they managed to reduce that while making use of the already quite low production emissions that we already have in the status quo. So they don't increase that. So those two options are actually the best ones. HVO is in the short run the best option. It's the one that reduces the emissions most. However, in the long term, the potential is rather limited. So in the long run, increasingly eFuels would need to be blended in. And it's really nice to hear that Liebherr has already started using HVO at their gates for test trials, etc. immediately after our study. We also looked at the hydrogen options, either in the combustion engine or in the fuel cell electric mobile crane. And yeah, here it really depends on the hydrogen source. When it's green, the greenhouse gas saving is significant. If it's gray, it shouldn't be an option. It's not worth it. It even could increase the CO2 emissions. And for battery electric mobile cranes, again, also for the current electricity mix, it actually increases the overall footprint, while with completely renewable electricity, it achieves a saving, but you might see the dark blue part is the production, and this is really increased because the battery that is needed is just so large. It's almost 3 megawatt hours, which is so almost 3,000 kilowatt hours, which is huge if you compare it to the usual vehicle batteries. You see like 60 kilowatt hours or something like that. So these are the results for the mobile crane. Looking at the time, I will just quickly jump over the other two results. For the truck mixer, we looked beside the status quo option at one that uses eFuels again. Then we looked at a mild hybrid truck mixer. There, the difference is that the mixing part is driven by battery electric engine, but the chassis is still driven by diesel. And we also look at a purely battery electric truck mixer, again, ones with a completely renewable electricity and ones with the current electricity mix. And here we see that using the battery electricity, drivetrain actually is quite sensible from a climate perspective, because that achieves the largest greenhouse gas savings, up to 86%. Of course, this is only true if the electricity mix is completely renewable. But the logic behind that is that the profile is quite constant, because the mixing goes on all the time, and you don't have a huge energy need at a certain peak point in time. And also you can use recuperation energy and fill up the battery, and therefore increase the overall efficiency of this construction machine. Then going on to the earth-moving machine, the wheel loader we looked at here. We looked at a rather small model where, again, we compared the current technological setup using diesel to one that uses eFuels, and also one that uses electricity, and the different electricity mixes. And here it really depends. So for the model we looked at, the battery electric version saves most emissions. If we look at a completely renewable electricity mix. However, talking to the Liebherr team, they said for the larger models, it's more difficult to find a technically feasible solution to use the battery electric drivetrain. So in that case, then the eFuels are also a feasible and sensible option. So overall, what we see is that the life cycle analysis show that depending on the specific requirements of the construction machines, different technologies are best to reduce the greenhouse gases for construction machines. And maybe just as the last talking point, recommendation for action that we suggest is that in general, climate policy needs to consider and incentivize the greenhouse gas saving and contribution of all technologies and across their whole life cycles. So firstly, life cycle analysis should be the base for deciding on which technologies are used, because all greenhouse gas emissions should be taken into account. And only with such a comprehensive view, climate-friendly decisions can actually be made, and thereby it can be prevented that emissions are just shifted towards other sectors where regulations don't look at. And also the life cycle analysis showed that effective climate protection, particularly in the construction machinery, must allow for technological diversity, because there isn't one single bullet that saves it all, but depending on the requirements, we need different solutions. Thank you.
Okay. Thank you very much, Teresa. Very interesting insights. Just to let you know, we are, of course, providing the slides later on, so that everybody can have a closer look. I have several questions coming in for you, Teresa, specific questions towards the study. So I would suggest I ask them, and maybe you can try to answer them as quick as possible. Some of them are short questions. The first one is from Friedrich Dehn. He was asking, did you also use a grid-connected option for the crane?
If we used a grid-connected option for the?
Yeah. Did you also check a grid-connected option for the crane? No,
No.
right?
No.
Yeah.
No.
But maybe then I would assume Friedrich would like to know why.
Because
Teresa,
because,
maybe I can answer this.
Yeah.
Sure, of course.
It's quite an easy answer, because the mobile crane is normally driving on the road. Yeah. So there is no grid connection possible.
No, yeah.
So the grid connection is only possible when you are standing on the job site, and to that time we had not such a machine in our product portfolio. We have it now, so but nevertheless, it's quite an easy answer. If the energy is a green energy, then you have no really, or let's say only a few limited CO2 emissions if it's grid connected. Depends on the electricity that you're using.
Understood. Thank you very much, Jürgen. Then Lorenz Schockert asks, were fuel cells not considered in these last cases? I assume that's about the last two cases you presented.
Exactly. Yeah, they weren't considered. So we did a starting workshop with the different teams, and they thought about which options they would like to think about and which ones they think are feasible. And for the later ones, they didn't want to look into fuel cell applications.
Mm-hmm. Then another technical, or not a technical question, actually a question about the study. Did Frontier evaluate hybrid machines with eFuels?
No.
Also
in this
no.
part, no.
Yeah.
Maybe I said we looked at this hybrid truck mixer, but we didn't look at fueling that with eFuels. So that was in the analysis, it was fueled with normal diesel.
All right.
I mean, maybe one comment to all the questions. Of course, you can check with Frontier everything that you like. Huh? And somehow it's a bit a commercial factor, of course. Nevertheless, you see on our product range, there is a big variety of different kind of machines. So you could ask, why didn't you have evaluated a drilling rig here made in Austria? So good question. The answer is we didn't do this because of the time, of the resources that we had, and of course of the money we wanted to spend, by the way. Nevertheless, in the meantime, after having the understanding of how to calculate these kind of machinery, and we are forced by our customers to do this now in certain business areas for each offer. So it is a task that we need to understand and need to fulfill on a daily basis and on a daily business. So we need to know how to do it. And then, of course, it is a more or less not easy challenge, but it's some kind of daily work to calculate these kind of product carbon footprints, yeah, or equipment.
But that's also good news for Frontier, because there's then room for a second study, right?
Yeah, exactly.
All right.
Well, people wanted to know how their products being calculated, because it was a quite. Thanks again, Teresa, for having us, or for doing this business with us. Yeah.
Falk Schneider is asking a question also to Teresa. Why is the production CO2 emissions higher for H2 IC EV? Oops, now somebody put away the question. Tobias, du darfst da nicht in den Fragen rummachen jetzt. So here we are. Why is production CO2 emission higher for H2 ICEV than diesel ICEV? So, yeah. Slide, I think it was in slide 13, if I'm not mistaken, but I may be mistaken.
Yeah, exactly. I can come back on that later on if you want to approach us later on. It looks a bit odd. I also saw that when preparing the slides. I need to look into it again. We finished the study 2 years ago. It took a while to publish it, but yeah, I also looked at it, but it had a reason. I mean, it's so obvious. We surely thought about it, but I cannot come up with it right now. I can come back to you on that later on.
All right. Okay, so we have some more questions coming in, but we also have some more presentations. And I think it's a good time to go on with the presentations and to widen the discussion a little bit, because we have 2 more off-road companies in the call who would like to present their thoughts and strategy, and also 2 fuel producers. And I think that would be also a question I would like to ask later to Jürgen and also to the colleagues from Steel and Deutz. and that is concerning actually the business opportunities. I mean, when I remember car manufacturers and truck manufacturers, when they talk electrification, they usually also talk infrastructure nowadays. So we see literally car manufacturers investing into charging infrastructure for electric cars, for example. That was not the case in former times. They never did that before. So it could be maybe also an option for Liebherr or Stihl or any other provider here to invest a little bit in e-fuel production and to provide for their customers not only the product but also the e-fuel. So just to put that into the room, I think that would be an interesting question. But first of all, maybe I would hand over now to Gunnar Hohlen. We have two fuel producers, as I said. Gunnar Hohlen is the CEO of Nordic Electrofuel, a company existing since 2016, based in Norway, which is quite interesting because it's not part of the European Union, and that might lead also to some questions later on. Gunnar himself is very active. We meet very often in several conferences lately, and it's one of the advanced producers because you are really on the brink to actually start. So it's not about talking future fantasy, which is very often said when it comes to e-fuels. And I would suggest, Gunnar, maybe you start your kickoff, your view on maybe also some of the questions we already heard. So where we are with e-fuels, what will be the perspective? Where are we maybe in 5 years and something like that? And also, of course, maybe give us some insights on where you are with your company. Gunnar, please.
Yes, thank you very much for that. May I share my presentation here? So, and it's coming up here. I guess are you seeing it all?
Yes, it's working.
Yeah, it's perfect.
Perfect. So yes, we've been working in Nordic Electrofuel since 2016 in order to get up e-fuels. We started very early with this topic. There were some data whether we could or there will come e-fuel into the market. I think will show in my presentation that that is something we are aiming to do, and I think we are in a position to do so as well. Our standard presentation start with a plane, as that sort of seems to be the hardest sector to sort of abate or sort of electrify, but I think it could nearly easily as well has been with sort of the crane or sort of off-road vehicles, as they are demanding a lot of electricity. You're talking sort of megawatt batteries, and thus it's very hard to sort of electrify those units, and also I think it's very important for sort of vehicles like that they can use it for the whole lifetime. And obviously using e-fuels, it's fully compatible with sort of the current infrastructure and enables a long lifetime. And we've seen from Frontier Economics that sort of the impact of using e-fuel is as large and maybe even larger than using sort of battery electrics. Going into our process, I think in this forum it's pretty clear how e-fuel is produced. So we do the traditional hydrogen process. We take CO2 from point source, we put that into the syngas reactor, and we take this into Fischer-Tropsch, and we have the green fuel, which can be used into the different applications. our CO2 is taken from a point source. We would also utilize the oxygen, and we even have some steam. So we're basically a circular economy. I have this slide to show that we've actually been around for quite some time, and we really made use of this time. We started as a pioneer into the e-fuel business that we early on saw the potential in this market. I think at that time, going back to 2015, e-fuel was viewed as too expensive, but we're working on getting that our product affordable, and we've been doing feasibility study, concept studies. We teamed up with the Technical University in Norway to do concept simulations. We've done the front-end engineering and design. We've done the FEL3, and we also done some post-optimization now. And we're basically ready to start construction, giving financing, and we're doing quite well on that point, but definitely open for investment if anyone would be interesting. You can see here our locations. So we're quite close to Europe. Our plant is in about 160 kilometers out of our capital, Oslo, and close connections then to Europe. You can also see the site we're having. That's our industrial park. It's the biggest industrial park in Norway, and obviously that we have all the infrastructure in place enable us to be quite cost efficient. So reducing capex quite substantially through that. We will start with a 10 million liter facility. We have sites where we are in close discussions with the stakeholders of putting up additional e-fuel plants, and we actually have an ambition of producing 1 billion liters only a decade from now. And we sort of start with 10 million liters. Next phase will be to produce have plants of 200 million liters, 160,000 tons of capacity.
Sorry to interrupt, but could you please start the presentation mode so everyone can see the slides a little bit better?
Okay, I sorry about that. I thought you had that. It's is this okay? Yeah. I would just like to say that we just signed a agreement with P2X Europe for offtake for all our production of our first plant. That plant is supposed to be ready for production in 2026. That will have a initial production of 8,000 tons per annum. And as I lined up, we will scale up following that, aiming to add 33,000 tons a year after, and also then to have 800,000 tons within a decade from now. So I think sort of going through this, that we definitely we see that we can be a substantial supplier to this sort of off-road segment, a segment which where it would be, I think, very needed to have e-fuels, where it's difficult to get charging out to the different location when these vehicles are working and machineries are working, and obviously the fact that you would be using e-fuels would allow those machineries to work 24/7, which, for instance, in the mining sector is you know, the norm rather than the exception. So obviously, using e-fuels, one thing is that you can have the same advantage of sort of cutting emissions, but I think also even more you can reduce the capex quite considerably compared to being fully electric. So think that sort of sums up my sort of introductory presentation.
Yeah, thank you very much, Gunnar. Maybe just one question which comes into my mind, because we heard, of course, from the beginning from Liebherr that eFuels are not available yet very much. You just said you started actually in 2016. I mean, that's 7 years ago. So the obvious question for me would be, why did it take so long? What were the obstacles, or what is really the problem here that we face as producers, that you face as a producer, that it takes so long to produce those products? Because I mean, as we saw in the study, and as we heard from Liebherr, and we will hear that from Steel and Deutz as well, we could hear that also from the airlines. There is no doubt that the products will be needed, right?
Certainly, it's a very good question, and obviously we wish we could have been faster to the market, but you know, the challenge is the fact that we see that initially a product will be quite a bit more expensive than the fossil fuel and currently also the HVO, and therefore it's hard to get buyers to pay a premium, and you know, without a offtake contract, you're not able to get the financing. So it's sort of pretty simple. I think we surpassed that by actually are able, even though it's not a mandatory market for eFuel before 2030, we will be able to deliver to a significant premium to the current SAF and HVO price, because there are buyers willing to you know, be part of using this and be part of this very important energy transition. I think that once we can, you know, scale our production, we can actually come down to, well, the prices of where we see traditional sustainable aviation fuel and where we see HVO. So it's a matter of being able to scale the technology, but obviously you need to start at a sort of smaller size. We find the sort of optimal size, this 8,000 tons, which our first plant is.
Yeah, well, I think, thank you very much for that answer. I think regulation plays also a very important role. I would suggest we come to that a little bit later, because we have another fuel producer from the United States also. And there is a very interesting development going on also with this Inflation Reduction Act compared to European regulation. But maybe I would get over to Steel now to get another perspective here. Andreas Steel AG is one of those famous, not so hidden champions actually in from Germany. The father of the chainsaw, you could say, founded in 1926. Nowadays a company which produces in the United States, in Brazil, in Switzerland, in Austria, in China, and the Philippines, so also quite globally. And we have René Schwerin with us. He is Manager Materials Science, Fuels and Lubricants at Andreas Steel. And without further ado, I would hand over to René, and please, René, give us your perspective.
Thank you. So here we go. Yeah, thank you, Ralph. Ladies and gentlemen, Ralph just mentioned we are a company who's almost 100 years old. And about 97 years ago, our founder Andreas Steel had a vision. Okay, here we go. Of making it easier for people to work in and with nature. So that was the driving factor to develop the machinery we know today, and that was developed in the past 97 years. And And I want to use this opportunity to introduce a little bit more of our company, because as Ralph also mentioned, we are very well known for our chainsaws, but we also do a lot more. Our products are used not only in the forestry business or agriculture business, but also for garden and landscape maintenance, in construction work, and also in private gardens. Steel has developed in the past decades very rapidly. In 2022, we had over 20,000 employees worldwide. I've mentioned our production sites all over the globe. We had a turnover of more than 5 billion euro. And one specialty of steel is we have more than 55,000 specialist dealers globally. So normally you buy our equipment directly from our dealers, so they can support everything, every question you have, and introduce you to our machinery. As mentioned, we are not only producing chainsaws, we also produce very different machinery to landscape and to take care of your garden and everything else. And what we also do, we also offer protective equipment, but also our operating fluids. That's what I'm concerned with. We directly supply our customers with fuels and lubricants. And we offer different kinds of technologies. In the past, it was purely gasoline and a little bit of electric equipment. And obviously, for the past about 15 years, the trend towards battery has also taken hold of steel. And we are amidst this transformation, there's a strong tendency to go towards battery-driven equipment. But as we've seen before with Liebherr, it strongly depends on the applications. So where it is possible and where it might not be so easy to use a battery-driven machine. For example, if you take chainsaws or brush cutters in professional work to manage, protect, and harvest your forestry, we are obviously in remote locations. The engine sizes vary between maybe 2 and 6 kilowatt. And during a typical work day, the consumption of energy is for a chainsaw, for example, 17 kilowatt hours. These 17 kilowatt hours is already the amount of energy that is used in the wood, and not obviously the complete energy you need to consume, because our energy efficiency in our two-stroke engine oils is not 100%, obviously. So you need more than the 17 kilowatt hours to run your engines. So if you compare the different possible technologies and what energy you need and what kind of battery weight you have for one complete day, you see here that for chainsaws or backpack blowers or other, for example, cut-off machines for the construction work, you are at a level that might be possible, but I don't see many of our forestry workers carry around battery packs in this range of weight. On the other hand, if you check for the fuel weight that you need for this whole day, it's in a typical range of, let's say, 2 5-liter canisters, or even only one that you carry around, and you can work the whole day. Another thing we took a look at is also hydrogen, but in handheld equipment, this is just not cannot be handled, and there's also no infrastructure for that. So our solution for that will be to still use the internal combustion engines. You could also find solutions to have a remote charging infrastructure, as shown here on the left-hand side. We're also looking into that. But still, it's a lot of investment to use that, and there's a lot of hassle for that. So on the other hand, if you use an existing equipment that you already have just change the fuel that you need. That might just be the best solution, because you don't have to change much infrastructure. You just have to find suitable sources for the fuel that we offer to our customers. And we will see a continued trend of battery electric driven systems also in handheld equipment, but we will also remain in certain applications, as I just shown you, especially in the professional surroundings in remote locations, where we are convinced that synthetic fuels will play a large role in the future. And here in a nutshell, just to give you again this quite impressive overview, if you have to decide, okay, to use the internal combustion engine with maybe 2 5-liter canisters of fuel, or you want to use this many batteries, I will not tell you what kind of investment you would have to take. Nevertheless, you will not carry that around in the forest. Even with increased energy density of batteries that we are also working on, this will reduce, but it will never be as close as this one here. So last year, we were able to offer our customers a not 100% fossil-based specialty fuel. In our equipment, we recommend to use always an alkylate fuel. It has many advantages. So we also were able last year to offer the first step into this new future of synthetic fuels. In this case, it's a product with 10% of bio-based material. We will increase that volume in the future. We see the bio-based material as a bridge towards the future and the eFuels that will be hopefully available. We are working on that together with the fuel producers and other stakeholders to find solutions to produce even alkylate fuel from synthetic methods in the future. But in the meantime, we see biofuels as a viable option because our volumes are not as high as in other fields of application. For example, I mentioned the 17 kilowatt hours per day. That compared to the 100,000 that one of the large trucks of Liebherr is consuming. So our volumes are much lower, and the bio-based products are a viable bridge towards the future. So I think I hope that I could give you some insight into what we are doing, and I'm very happy to answer any questions that you have later on. Thank you.
Thank you very much, René. Maybe just one question to understand this a little bit more into detail. So is it the usual business that you are also providing the fuel for your customers, or could you, is that even mandatory? So you tell them for quality reasons or for warranty reason, whatever?
Well, we only can recommend to use this special alkylate fuel. In some areas of application, it is mandatory. For example, in certain forestry applications, if you are working in a public forestry business, you have to use this kind of fuel, and it's always a good idea to use this kind of fuel. It is more expensive, so our customers already pay a premium for this kind of fuel. But it has many advantages, especially for your own health, because the fumes that you're always exposed to when you work with a handheld equipment are much less harmful compared to the regular pump station fuel, which contains obviously high amounts of aromatics. So there's a big advantage if you use this kind of fuel. Our dealership offer this kind of fuel in certain regions, mainly in Western Europe, in North America, Australia, New Zealand. In other maybe less developed and less rich countries, in the end, this kind of fuel is unfortunately not yet available, but we hope in the future this market will grow because it has many advantages.
All right, and do you have a number? What amount of fuel you are selling every year?
Well, we sell a lot, but in the end, it's more than 20,000 tons a year, which might be in the low range of total volumes consumed by our machinery, because in the end, it's not mandatory at the moment. A lot of people, unfortunately, don't know about this fuel, so they just use pump station fuel because they know better. And in other regions, it's not yet available because of price issues, because it is more expensive. in the end, that's always the cost. You have to pay. Higher quality will cost more.
Okay, but the interesting thing I would say is that you have the distribution channel already
Yes.
in place, where you, of course, then would also provide eFuels at the end of the day. That is very interesting. Thank you very much.
That's our goal. We have the direct contact to our customers. Yes.
Yeah. All right. Okay, so thank you very much so far. I assume there will be more questions later on, from the smaller machines now to the big ones. We have Deutz, the company Deutz, with us, and namely Andreas Plumpe. He is working for Deutz since 2017 and is in the development management of Deutz AG, focusing on methodology, development, strategy, and sustainability. Of course, Deutz is also not only very well known, but a very traditional German company. It was founded in 1864, and of course is known especially for, if I make it an untechnical word, for big machinery or bigger machines, up to 620 kilowatt hours. Especially of highway applications. So very interested in your perspective, Andreas, and please, you have the floor.
Yeah, thank you very much, Ralph, for this very kind introduction and for having this opportunity to speak here to all of you. I just share my screen. All right, is the presentation visible?
Okay, perfect, thanks.
Perfect, okay. So I would like to use the next 10 minutes to give you a brief introduction into our strategy in how to defossilize our portfolio and therefore at least parts of the off-road ecosystem. So Deutz at a glance. Certainly the name Deutz might be familiar to most of you, known for especially agricultural machinery and air-cooled engines that made the company successful in the 20th century. And it all started with Nicholas August Otto. Ralph, you just mentioned it, founded the company in 1864, and his desire for better solutions, for improvements, made him think about faster or quicker solutions for mobility. And that made him invent the engine #1, the first ever combustion engine that still exists. And this made the company successful. And he invented the gasoline engine, and Deutz quickly became a company with international reputation. So for more than 160 years, Deutz has been supplying diesel engines for vehicles and machines all over the world. And today our core competence is the development, the production, and the sales of innovative drive systems for different application segments all over the world. So we are tier 1 supplier for construction machinery, for material handling, for the agricultural sector, and also for stationary system. And the last part is other, that mainly refers to our subsidiary Torqeedo, who are providing electric boat motors. And Deutz is in the transformation. And why is the transformation necessary? So our diesel engines power industries that are responsible for huge amounts of CO2. And we evaluated this on an exemplary construction site that you can see here on this slide, where we took into account 4 applications: a wheel loader, 2 excavators, a smaller one with 100 kW and a bigger one with 200 kW, and a blacktop paver machine that actually lays the asphalt on the streets on the construction site for building roads. And assuming a typical duty cycle and assuming typical operation hours per day, we see that only this construction site, consisting of 4 applications, emits around about 140 tons of CO2 per year. And considering that Deutz sells more than 150,000 diesel engines per year, we can see that the potential for reducing our Scope 3 emissions here is huge. And we want to make use of this potential. And that is why we are committed to making our company climate neutral by 2050. And on the other hand, we see growing demand for those powertrains. When we look at the applications that I just mentioned and the main segments, construction, material handling, and agriculture, in a power range between 19 and 560 kW. We see that in the next 12, 13 years, an increase in demand will happen by almost 30% of these applications. And that is because mankind is growing and prosperity, the desire for prosperity in mankind is growing, and all that needs to be covered with housing, with food and infrastructure. So we need powertrains to keep the world moving, and renouncement is no option. And the question is, how can we solve this problem, and how can we do this transformation? In order to do that, we have to define a solution space. And for that, a deep, profound understanding of the energy system and therefore energy carriers is necessary. And what we see here is the world's final energy consumption in 2021 on the left-hand side. And for simplification, we divided the energy consumption in two variables, let's say, molecules on the one hand and electrons on the other hand. And we see that in today's energy economy, electrons only contribute 20%, and the dominant amount is provided by fossil molecules. This is more than 2/3 here in this 2021 numbers. So on the right-hand side, we see a scenario conducted by the IEA. It's a APS scenario, announced pledges scenario, which takes into account all measures that are announced by governments to mitigate the climate change. And for instance, what is included here is the German ambition to become climate neutral by 2045. And in this scenario, we see that, and that is a good message, that electricity doubles between 2021 and 2050. So from 20 to almost 40% of the whole energy consumption. That is a good message. But on the other hand, we see, and that is particularly striking here, is the fact that molecules are still dominant, and with more than 60% of the cake, and especially fossil molecules are still playing a major role here with more than 1/3 in this scenario. So what could be an answer to this? And what is only partially taking into account is a potential of renewable fuels, and that's what we have to talk about. So what we see here on the outer layer of this cake, let's say, call it like that, is the status quo of biofuels, first generation and traditional biomass, which today contributes around about 10% of the final energy consumption. And we see that biofuels of the second generation, like HVO, for instance, can also contribute another 10% to the whole worldwide energy consumption. But as we all know, due to limited feedstock, these capacities are limited, and that is why PTX or eFuel products must play a decisive role here. And what we see here, this 47% of the final energy consumption is almost half of the energy consumption in 2050, and that is not a physical potential what we see here, but rather a potential that takes into account geopolitical stability of governments and socio-economic factors. So really talk about what is feasible, not only technically but only economically, and that is a huge amount. So we need to harvest these almost 50%. On the other side, and that is particularly important for this event here, is the question: what is the demand of the off-road application? And beyond the energy carriers, we must understand that off-road applications are not the same. They're very different and have a big variety. And the ecosystem is manifold, and we see that it varies, especially in terms of energy demand, so duty cycle on the one hand, that's the x-axis, and the degree of mobility. So let's call it a distance to an energy infrastructure. And on the one hand side, we see light duty applications like this telehandler or a towing tractor on the airport, or forklifts, for instance, that are applications that have the best preconditions to be electrified. And that's what we already do at DEUTZ. But on the other hand, there's heavy duty equipment like wheel loaders, big wheel loaders, like dumpers, like tractors, or I think Mrs. Steinfort already mentioned this mobile crane they have huge energy demands, and the sizes of the batteries would just not be suitable for these applications, apart from those machinery being operated in areas that are very rural and not having access to energy infrastructure. So we see that the applications are very versatile in terms of load profiles, and that is why there is no one-fits-all solution for non-road mobile machinery. And that leads us to our strategy from DEUTZ. We see based on the preliminary considerations that I just showed you, we see a double strategy, or a two-lined strategy. On the one hand side, which is on the top here, we think that sustainable fuels that power internal combustion engines must be one pillar for a future sustainable ecosystem. And on the other hand, we have a well industrialized electrified powertrain ecosystem that we built up in the past 5 years, and that is the second pillar of this. So we need the best of both worlds, and that brings me to the conclusion. And I will want to come back to the initial question of this event: all electric for off-road applications. And I think that is very, or puts I can put this very well into the narrative of this event, that it is not a question of either or, but rather both. And we believe that there's more than just one road for a green off-highway mobility, and that is the DEUTZ strategy. Thank you very much for the attention, and I'm happy to answer any questions.
Thank you very much, Andreas. Very impressive. Maybe two quick questions, if I may, before we go to our last speaker, and have then a final question and answer round also from the audience. So if you have additional questions, I think we will strive some of them you already asked, but if you have additional questions, that would be the right time now to put it into the F&A. So first, a rather maybe a more strategic question, seeing your last slide. I mean, what we hear very often from industry, for example, the car industry, which is heavily regulated in terms of CO2, we cannot invest into several technologies in the same time. We cannot afford that. That is why we, for example, need to go all electric. So your strategy obviously is a very different one. So you actually have the strategy and have decided to invest into different technologies. So how you deal with the problem, with the obvious problem that, of course, the amount of money you have to invest into research and development and into different technology pathways also to produce, of course. How do you deal with that?
Yeah, thank you. That is indeed a very good question, and we are often asked such questions. So it is indeed not easy to select the appropriate technology, even if there's the solution space is very big, and that is why we are really looking very deep into each technology and evaluate what types of the ecosystems we want to serve. So, for instance, in the electric drive systems, we develop 48 volts and 360 volt systems, but we are not ready yet for saying, yeah, we have to go 100% into 700 volts or even higher. So there's a big evaluation happening here. And of course, it is investment, a lot of investment that we did. We invested over 200 million in electrification in the past 5 years, and that is financed by our EBIT in the end. So it is how it works, and we think, but we are really sure that this is needed, because and what I just showed, that there is no not only one or only two solutions for off-highway mobility.
All right, thank you. And now we just got a question specifically for DEUTZ. There is obviously a tractors fan in our audience. So what solutions do you see for tractors? Is the hydrogen combustion engine usable for mobile machines like this?
Definitely it is. So the internal combustion engine based on hydrogen is something we have in scope. That is, we are a front runner here indeed, and we want to go to the market in serious production with our first hydrogen engine in next year already, in a stationary application first, but later on also in mobile applications like a tractor. And we see that from the perspective of the combustion system and the powertrain itself, there are no major changes. So it's more or less the same engine compared to a classic diesel engine. The challenges that we face here is architecture of the application itself, so tank systems and tank infrastructure.
So that also answers the second questions, which was about the status of DEUTZ hydrogen motors. That's basically what you answered.
Series production next year.
All right. Okay, so far, thank you. Please stay with us. We will have some last questions later on, but I would now hand over to Andrew Miller, our second fuel producer in our event today. Andrew is representing Infinium Electrofuels, an US-based, even California-based company, which I rather really like, I have to say. Also a member of the eFuel Alliance, and with several production sites coming up, not only in the US. So that's why you're also interested, of course, in for example, in Europe. But maybe we come to that a little bit later after your presentation. I would say, please take the floor and give us your perspective then.
Thank you, Ralph, and thank you everyone for this opportunity to contribute to the discussion. You know, we need all of the above solutions for decarbonization. I'm a strong believer in eFuels, and let me give you a little bit of an introduction to Infinium and some of the benefits that we see for the eFuel universe. And great. Can you see my screen?
Perfect.
Wonderful. So Infinium is a California-based decarbonization platform focused on eFuels. We have development opportunities in the US, several in Europe, Scandinavia, and around the world. And we are completing construction of our first facility in Texas with the intent to deliver eFuels to Amazon later this year. We focus on three primary products, that being the sustainable aviation fuel, diesel, and then an e-naphtha that we view as a great feedstock for the petrochemical market. You know, we see e-fuels with their near zero carbon intensity at plant gate as being one of the most cost effective from a cost of carbon abatement for many sectors. E-fuels brings a number of other benefits as well. Synthetic fuels have benefits across particulate matters, nitrous oxide, NOx, and other emissions. There are benefits to local communities as well. I'll also note that synthetic fuels have tremendous stability properties. So for operations like data centers where that fuel might be sitting for some time, or in a distribution network where the lift might not be of significant volumes on a regular basis, those synthetic fuels do have tremendous benefits. Quick snapshot of the Infinium fuels process. We take renewable electrons and turn them into renewable molecules. How do we do that? We utilize an electrolyzer to produce green hydrogen, combine that with captured or recycled CO2 to run through the Infinium's fuel synthesis back end. That is a proprietary system. The FT-like system has been deployed on small scale in North America in a number of sites and is commercially proven. We also include a reverse water gas shift, converting our CO2 to carbon monoxide. We're technology neutral on the electrolyzer. We look at both the high pressure alkaline as well as the PEM, and are monitoring some of the solid oxide technologies that are emerging. We're very excited to see the supply chain for hydrogen grow. We think that there's tremendous opportunities for cost reductions in the electrolyzer space, and we'll continue to work with a number of different suppliers on that front. Infinium is supported by a number of tremendous partners, both capital partners as well as commercial partners, names like Amazon, NextEra, Mitsubishi, SK, all tremendous names, have been tremendous supporters. Our first facility, which I'll talk about here in just a second, is on balance sheet. Our second facility is will be on balance sheet as well, and that's only achievable through the support of strong partners. You'll see on the commercial side, we've got a few names that have a European focus. I'll talk in a second about some of our European projects as well. I mentioned our Corpus Christi project in Texas. That's going to be producing fuels a little bit later this year. That will be producing e-diesel that will be going to Amazon for their middle mile fleet to help address their decarbonization goals. In addition to the Corpus Christi facility, we have another facility, what we call a Roadrunner facility, which is a brownfield conversion of a gas to liquids project. We're reducing SAF, diesel, and naphtha at that facility. And we have a number of what we call the large-scale projects in the public domain on the reuse project in Dunkirk with ArcelorMittal and LG. We've got projects underway in Scandinavia. And then just from a US perspective, I personally believe that the incentives and legislation that's been put in place in the US around green hydrogen, combined with the very active and robust renewable power markets, both from a wind and solar basis, created a tremendous nexus for eFuels. I think you will see eFuels being made in North America and being exported to the UK and EU. That's my presentation. Look forward to Q&A.
Thank you very much, Andrew. Very comprehensive. So looks like when I take the 20,000 ton, for example, steel would need, you would be ready for that soon, right?
Absolutely.
So maybe a little bit of a forecast. I saw this last number on your last slide, but if everything, and that would be my major question also to you and to Gunnar for the closing, because of course regulation plays an important role. Now you are an American company which is also invested in Europe. So you see the US regulatory framework as well as the European one. In both cases, we have very different approaches in Inflation Reduction Act versus Renewable Energy Directive. Now Gunnar is based in Europe. I would assume he looks also into opportunities in the United States, for example. So maybe you could give us some judgment on where we are regulatory-wise, and what would you, when you compare the two markets, because here in Europe we have this debate about how forceful the Inflation Reduction Act is, but how you judge that and how you particularly see the situation in Europe. And that would be also the same question to Gunnar, actually. By the way, Gunnar, that's why I said he's based in Norway, which is also not part of the EU. So you could also go a different way in Norway. That perspective would be, of course, also of interest. But Andrew, please.
No, it's a great question, and as a producer, you look at the various regulated markets and trying to solve the equation for all of the regulated markets with the different requirements can be a challenge. I was on the phone just yesterday with the Department of Energy as they're considering temporal matching requirements for hydrogen production. And there's an acknowledgement that the trend line should be that these regulations should come together over time, but inherently you're going to have differences. In the US, as you know, we like to use incentives and tax credits, and so a different approach than maybe some of the mandates that are seen in Europe. It'll be very interesting to see how the market responds and where those fuels will flow as production starts to ramp up and supply grows.
Gunnar?
Yes, no, definitely very good questions. It's been a challenge, I think, for us and others that regulation hasn't been ready. We see that Europe is sort of using the stick and mandates, and in the US it's more been the incentives and carrots. I think that still there's quite a bit of uncertainty on regulations. I mean, we've got in place for the aviation, but the many markets still sort of not covered, and uncertainty there, and also within aviation even, we don't know whether the 2030 when we have the Refuel EU Aviation, whether the book and claim system will come in place, as there's a lot of discussion about, and would be beneficial in order to bring out eFuel in a more efficient and affordable way. And there's also question, are code processing allowed, etc. So still quite a bit of uncertainties, but we're slowly getting there.
That leads me to a question from Lawrence Schockhart, which is of course very interesting concerning the also in the circles of the eFuel Alliance widely discussed EU delegated acts, and here especially the question of the CO2 sources. Gunnar already mentioned that that Nordic Electrofuel is having a CO2 point source in place. Of course, that is regulated in the delegated acts. How is Infinium doing that? And is maybe also another question for both of you, also direct air capturing in your picture there?
So just to address the source of the CO2, of course, the framework for the EU has specific requirements. We do not have ETS type of mechanisms on our CO2 emitters in most of the US. So much of the industrial CO2 would not qualify for the EU. You really would be looking at biogenic CO2. In the US, there are a number of large pipeline efforts. They're looking to aggregate biogenic CO2 from ethanol sources. Not all of those ethanol sources will qualify, but the expectation is that biogenic CO2 would be, some of that biogenic CO2 would qualify in the EU. And then, I'm sorry, now I forgot the second part of your
direct air capturing.
Yes, on the DAC. Look, we are hopeful that DAC costs will come down over time. If you look at the 1.5 disclosures on their cost of carbon, they're still at about $400 a ton. They expect to get it to $250 a ton. That's significantly higher than we see for CO2 from other sources. And so that cost will have to come down for it to be competitive here in the US.
Gunnar, maybe quickly on that.
Yes, certainly. I mean, we as I said, we're using industrial CO2 and a point source. Our point source will be biogenic, but I think there's many industrial point source, and I think sort of for the early movers, one shouldn't have this limit by 2041. I mean, that leaves us at the mercy in 2041. If we have that to actually change to direct air capture, and we're working very closely with several of the suppliers of direct air capture. We're watching what they're doing. We're talking to them. They all have an ambition to really come down in cost. Hopefully by 2040, we can have costs there in the area of sort of $100, $150 euro per ton, but you know, it remains to be seen. I mean, it shows that they need to go down about, well, reduce their cost by sort of 80-90% compared to today.
There is one question from Ernst van Gelder. Maybe Andrew and Gunnar, you could look into it in the chat because it's quite specific, and we are running out of time, unfortunately. And I would like to bring in Andreas, René, and Jürgen for a last round of remarks. There is one question from Gregor Henn, which I think is very good for closing remarks, so to speak. I just read it out. So it seems as if we all agree that e-fuel have to play an important role. I think that's clear. Their defossilization potential is high and could be quickly implemented due to the existing infrastructure. What do you do that it becomes reality as politicians and consequently companies seem only to focus on electricity and hydrogen infrastructure? Of course, that could be a question for the eFuel Alliance as a whole. I would refer to our homepage there and see all the position papers we are having on several regulatory issues we are discussing right now under the Green Deal. But leaving the question to you guys, so if you see the situation your companies are in, and of course the pressure you are having to come to new solutions, even though if you are not directly regulated right now, what would be your, so to speak, wishes you would have from politicians to solve these problems or to help you with that? I don't know, maybe René, would you like to start?
Yeah, sure. Our situation might be a little bit different. We already talked about the special quality that we need for our fuels, and so and we have the direct market with our customers. So what we are doing at the moment, we try to find a technology and partners to produce this kind of stuff in the future. As I mentioned in my talk, the bio-based product is for us a bridge into the future, and we see e-fuel as a solution in, let's say, 5 to 8 years. So what we do at the moment, we talk to all different stakeholders, to companies who want to produce stuff, who want to produce methanol, who want to produce hydrogen, who are involved in direct air capture. And we are talking to everybody, and we try to set up our own, probably our own streams together with partners who are also interested in this kind of specialty fuels. We are also in talks with other stakeholders here surrounding the southern region in Germany with big automotive companies, for example, to also use this kind of fuel. And hopefully the regulatory basis here in Europe will also take into account that this special applications will need, otherwise we won't have a future, obviously, and that cannot be the interest of everybody.
Yeah, but so sounds like steel could be an off-taker. So if, I don't know, if you didn't talk to Gunnar and Andrew yet, maybe you should do so after the event. All right. Yeah, Andreas, please.
Yeah, for us, the situation is a bit tricky because as a tier 1 supplier, we are kind of tied in the value stream of the ecosystem. But what we do to facilitate it and to foster the situation of e-fuels and the production capacities is that we go to conferences, that we try to do as much lobbyism as we can as a company, as Deutz, and we're also considering investment in e-fuels. So we're trying to do as much as we can to leverage this.
Jürgen? You need to unmute yourself, sorry.
Maybe 2 points from my side. One is maybe only a wish that politicians should come back to a non-ideological discussion. Maybe this is a nice wish, but something. Nevertheless, what should be done? First, I mean, all is depending on the amount of renewable energy. Independent of the technology behind. If you're using batteries and the batteries are coming from coal, burning of coal, fossil coal, then it's good for nothing. So the amount of renewable energy must be increased drastically. So get rid of all the bureaucracy to erect windmills or solar stations, whatever. So this needs to be done. And of course, as everything is depending on the availability of energy, the piping, the networks of currents, of hydrogen, whatever it is, needs to be supported, because we need to transport and to distribute the energy. And if this is not done properly, then we stick with our machines, with our equipment somewhere in the desert and having nothing. So this is maybe not a technology wish, but trying to focus on get rid of the slowliness, and this is hindering, I would say, not only Liebherr but the overall society.
I mean, what I find interesting and actually intriguing, and this event does show that, I think, the sector you are in is so diverse that there are definitely no one-fits-all solutions possible.
Yeah.
And that is also what the Frontier study actually shows. And that is also the philosophy of the eFuel Alliance. I mean, we say electrify when you can. That can be a viable option, but of course it's not the only option. And then the interesting thing is, because we have these heavy debates on regulations in certain areas, such as now is trucks on the table in Brussels right now, the CO2 targets for trucks. So that's partly also very ideological, these debates. This is a problem you do not have directly in your sector right now. And that can be also a positive thing, because it could be a role model where you provide strategies and solutions also to politics by yourself, so to speak, not by regulatory pressure or by heavy-handed political debates. But of course, Jürgen, I fully agree. Of course, you need the energy and you need the, for example, the fuels for that, and that is what Gunnar and Andrew and many other members of the eFuel Alliance who will produce fuels or who are producing eFuels already will provide.
I mean, what can we do quite easily, and we have done it already. After the study of Frontier showing that HVO is a suitable solution for mobile cranes. Our mobile crane work, which uses for production and testing 2.5 million liters of fossil diesel every year. They switched completely. So there is no fossil diesel in this company any longer. And I mean, this is where you can make your advertisement. You can say, okay, look on this. If you use it every time, with every tank fill, saving 70% of CO2 over the whole life. It's easy.
All right, 5:05. Still 70 people are in the call, so I would say not bad. Very interesting insights, very interesting presentations, and also very interesting discussion. Thank you to all our audience for the questions. Of course, the event itself will be is recorded and will be provided on our homepage and on our YouTube channel. Also, the presentations should be available soon. And I would like to thank my team, Jan for the technical support, Lars Hummel for the preparation of the event itself. I would like to thank all the panelists. And with that, I wish you a wonderful rest of the Wednesday, a wonderful week, and stay safe and healthy, everybody. Thank you very much.